Hello students and seekers of truth. We continue our study of rational functions here with yet another example of a word problem. So you have 200 milliliters of a 35% acid solution. How much pure acid needs to be added until you get the concentration to go up to 40%? And so I'm going to draw a cartoonish picture here to maybe help understand the problem. So say you have a beaker here and there's some liquid inside. So there's some total amount of liquid that's filled up in here in this beaker, the stuff that's in blue here. And this amount here is 225 milliliters, okay? And that's total, right? But only 35% of that is acid. So like only this much, and I'm going to use the purple here to describe the acid amount. So only this purple here, this purple section right here is the acid. Okay? And how much acid is that? Well, 35% of 225. So that's 0.35 times 225. Okay? All right. So now how much more acid do we need to pour in here so that the total amount, the purple compared to the blue, will be 40%? And so I like to represent this situation as what we have and then kind of add to it to see what we need. So at the moment we have 0.35 times 225. That's how much acid is in this beaker. And this is how much total liquid is in here. And let's just say here that X is the answer we're looking for, is the additional amount of acid. Notice here when we divide this, of course, we're going to get 0.35 because 225s are going to cancel. That's a 35% acid solution. So now we want to add acid to this, to more acid into this cup. So more acid is going to flow into this cup here, and so we're going to add some X amount here of acid. But note one thing, that when you add acid into the amount, it doesn't just increase the amount of acid, it increases everything, right? So now the water is going to, both the water is going to and the total amount of acid is going to increase. So the denominator is going to increase by X as well. So how it's kind of like the free throw example. When you make a free throw in that acid in the numerator, you also have to add one to the denominator because you also attempted a free throw. So, but now we want our total amount, our total percentage to reach 40. In other words, 0.4%. Sorry, 0.4 or 40%. All right, so now from here, we have a pretty nice equation that we can work with, and I'm going to solve it from here. Okay, so I'm going to multiply everything by this denominator. So I'm going to get 0.4 times 225 plus X. And on the left side, everything remains the same, 0.35 times 225 plus X. They look kind of the same, they sound kind of the same, but they're quite a bit different. Okay? So now let's do all of the extra work here. Let's distribute. So 4 times 225, that's 100, so that's 900, or 90, excuse me, plus 0.4x. Over here, 35 times 225 gives us 78.75 plus x. We are going to collect our like terms, so we're going to move this to the left side, and we're going to move this part to, sorry, the 78.75 to the right side, and what I underline in blue here, 0.4x to the left side. So that's how, let's see how this looks. So this is going to be x minus 0.4x equals 90 minus 78.75. Okay. X here is just 1x, so 1 minus 0.4 is going to be 0.6x, and 90 minus 78.75, that is going to be 11.25. Then divide both sides by 0.6. and we get a nice clean 18.75 milliliters. So that means if we add 18.75 milliliters to our little cup or our beaker, then the total amount of liquids is going to increase, but because it's pure acid, the concentration of acid is also going to increase, and that will get the concentration to reach 40%. So there you go, another example of the fun world of rational functions. Keep working hard, ask for help if you need it. Thank you for watching, and have a wonderful day.